Okay. So we are on chapter 3, Valence and Ionic Compounds, part 2. So we're trying to understand the relationship between the charges on ions that are going to be in ionic compounds and what group they are in. So what we have here on this periodic table is kind of a simplified version of what we did in the last video. So we can kind of stick with our old one, or we can use the new one. Either way, you should have watched part 1. Okay, so can we use the periodic table to determine the number of valence electrons for main group elements, and if so, how? Well, so yes, we can. Absolutely, yes. And if you remember from the last video, right, our group number is actually equal to the number of valence electrons, right? And so that's part of it, right? But that just tells us our number of valence electrons. And so there's kind of 3 scenarios that are going to happen, right? And in the very first scenario, right? So if an atom has less than 4 valence electrons, what's going to happen? Well, things that have less than 4 valence electrons, that is, group 1A has 1, group 2A has 2, group 3A has 3. Those are the only 3 that have less than 4 valence electrons. So if an atom has less than 4 valence electrons, is it going to gain or lose its valence electrons? Well, in every single one of these, we're over here, and we are lose, lose, and lose, right? So if we have an atom that has less than 4 valence electrons, so when it becomes an ion, so when it becomes an ion, it will lose its valence electrons. It will lose its valence electrons, right? Okay, so that's like one thing that could happen. So it's kind of like scenario 1. Okay, scenario 2. So if our atom has more than 4 valence electrons, what do you think is going to happen? Well, okay, let's see. Come over to our periodic table. We say, okay, where are the columns where we have more than 4 valence electrons? Well, that's group 5, group 6, and group 7. More than 4 valence electrons, but not 8, right? I guess we should add that, but not 8, because if they have 8, that's a noble gas and nothing will happen, right? So make that exception. So if your atom has more than 4 valence electrons, but less than 8, then it will gain, right? All of those in 5A, 6A, and 7A, all of those we said gain, and where was it? Oh, here, gain. So all 3 we said they were going to gain. So it will gain valence electrons to complete its octet. Okay, so let's kind of think about this. If our atom is gaining valence electrons, these are going to become negatively charged. If they're going to become negatively charged, they're going to become what's called anions. So we'll put it in behind negative, right? So our first scenario, if it's going to lose its valence electrons, it's going to become positive, which is a cation, because cations are positive, like a cat. Positive. Okay, so those are our 2 scenarios, and really noble gases are our scenario number 3, right? If they have if they have 8 valence electrons, they're a noble gas. and nothing will happen. Nothing happens. You have no ions, right? So there's only one other possibility that could happen. You have less than 4 valence electrons. You have more than 4, but less than 8, or you have 8, right? And the very last scenario that can happen is if an atom has 4 valence electrons. If it has 4 valence electrons, it's similar to the noble gases in that no ions will form. Ions will form, but it's not stable with 4 valence electrons. So these atoms will share their valence electrons. And that's later in the chapter, we talk about covalent compounds or molecules, covalent molecules, right? And that's what happens with those atoms. So those are our different possibilities that could happen. All right, so now we're going to go. How many valence electrons are present in? All right, so if we're going to do an atom of chlorine, let's both do an atom of chlorine and an ion of chlorine. I kind of want to think about this, right? So if I have an atom of chlorine, that's simply Cl. I find that on the periodic table. Cl is in group 7A. So how many valence electrons? It has 7 valence electrons. An ion of chlorine. What is an ion of chlorine going to do? Well, to become an ion, chlorine's going to gain 1 valence electron, and it's going to become Cl minus. So now that chlorine ion has 8 valence electrons, because to go from the atom to the ion, it gained 1 valence electron. So you should be able to do that for any element that I give you. B, an ion of bromine. Okay, let's see. I just got to get rid of some of this stuff. This is it's too much, right? And you've copied it, or you can rewind the video and you can get all the things here. It's just crowding me too much. Okay, so let's kind of change color here. All right, so an ion of bromine, and let's also do an atom of bromine. So let's start with an atom of bromine. An atom of bromine, if we are bromine, we're right here under chlorine. So bromine also has 7 valence electrons. So what's bromine going to do to turn into an ion? So this bromine, plain old bromine, would be 7 valence electrons, but bromine ion is going to gain 1 valence electron. So now it's going to have 8 valence electrons. So I'm going to have to call it Br minus, right? Just like I did Cl minus, that's a superscript, that's the charge, and that's how we write it. Okay, how about an atom of neon? And we've been doing this, an atom and an ion, an atom and an ion. But what is neon? Where is neon? Neon's over here in the noble gases. It's in column 8. So an atom of neon just has the symbol Ne, and it has 8 valence electrons. So is it going to gain? Is it going to lose? No. Are we going to form an ion? No. How about an ion of potassium? Here's potassium on our periodic table. It's in group 1A. So let's do an atom first, an atom of potassium. So that's K would have 1 valence electron. Now here's where it's just a little bit tricky. And you got to remember, let me kind of erase some of this other stuff, that if it's potassium, if I go to the potassium ion, in order to do that, I'm going to lose 1 valence electron. So if I start at potassium, potassium has 19 electrons. If I lose 1, I'm going to look like the element that has 18 electrons. So I come over here and I go, okay, well, argon, right, is in the previous period. It has only 18 electrons. So my potassium ion is going to have 8 valence electrons, just like argon does. And that's what gives it that stable outer shell. And that's what our atoms are always, always, always trying to do. Okay, we come over here. Let's see an atom of barium, and we want to also do an ion. So our atom of barium, so let me erase a little bit of this stuff. Okay, so we want an atom of barium, and we want an ion of barium. So if we look for barium, so we're down here, we want to come up and we're going to say, okay, that's 2 valence electrons in the atom, 2 VE. So what is barium going to do? It's going to lose those 2 valence electrons. And so if it loses those 2 valence electrons, if it loses 1, it looks like cesium, right? That's 1 less. And then if you go back 1 more, you got to go all the way to the previous row. It's like you're reading text backwards, but you're just kind of following the numbers on the periodic table, because barium over here is 56 protons or 56 electrons. Go down one that's 55. Well, where's 54? 54 is all the way over here at xenon. So the barium ion has lost 2 valence electrons. Now it has a complete outer shell. It has 8 valence electrons in its outer valence shell now. And because it lost 2, now it lost 2 negative charges. So now it has 2 more protons than electrons. And if you'll notice, sometimes on the homework system wants 2+. It does not want BA +2. I'll accept either one, but for your homework, this is the one your homework wants. Okay. And make sure you use the superscript when you're doing that. All right, so next one, we want an atom of krypton. So we're going to erase some of our stuff, and we got to find krypton. So krypton is over here, and it is a noble gas. So are we going to find an ion of krypton anywhere? No. So we're just going to go with the atom, and krypton has Kr, and then it is in group 8A, so it has 8 valence electrons. Okay, an ion of fluorine, let's do an atom first. So I'll do it down here, an atom of fluorine. That's F. So fluorine is right here. It's a halogen. It's in group 7A. So it has 7 valence electrons. So now an ion of fluorine, to go from an atom to an ion, what's going to end up happening is fluorine's going to gain 1 valence electron, and now it's going to have 8 valence electrons. So if here is fluorine, fluorine's number 9, it's going to gain 1 more valence electron. Who's it going to look like? It's going to look like neon, and it's going to have that complete outer shell. And so we say it is F-, and we don't put the 1 because it's chemistry, and we know the 1 is understood. Okay, so how are the ions formed with a +1 charge related to one another? So if we kind of erase this stuff and we want to go find who's got a +1 charge, well, everybody in group 1A has a charge of +1. So how are they related? So all of these atoms, so all atoms with a +1 charge, or a 1+ charge, right? Whichever way you want to say it, charge, are found in group 1A, right? All of them also have 1 valence electron, and they're not really happy with it, right? And most of them, with the exception of hydrogen, hydrogen's a weirdo. Hydrogen could gain an electron and look like helium, or it could lose an electron and it's just all that's left is a proton. So hydrogen can be really weird, but everybody else, everybody but hydrogen, they are going to we'll say all, and put it in parentheses, except hydrogen, will lose their one valence electron, right? And when they lose their one valence electron, they're going to become an ion with that charge of +1, right? So you can see where that information is coming from. All right, next one. Let's see. And I think, well, we'll still leave it, but I'll shrink that area a little bit. All right, so if an atom of sodium contains one valence electron, and do we agree with that? Here's sodium. Sodium indeed is in group 1, so it has one valence electron. And it becomes an ion of sodium. It contains 8, it should be 8 valence electrons. Should be valence electrons, and has a +1 charge. What did the sodium atom do to become a sodium ion? Okay, well, let's start with that atom. Here's our atom. Our atom is just plain old Na, right? An atom, any atom of sodium, I've kind of written all over it over here. So if I look at sodium right here, that 11 tells me the number of protons. That's the atomic number. So I have in an atom of sodium 11 protons, and I also have 11 electrons, because in every single atom you have an equal number of protons and electrons, and so the atom is neutral. Because if I have +11 and -11, what's my net charge? 0. That's how I know I have an atom. And if I look at these electrons, tell me about these electrons. In these 11 electrons, 1 electron is a valence electron, right? The rest of them, so there are 10 left, 10 valence electrons are inner electrons. And so if I were to, I think I did this in the last video, I drew the atom of sodium, right? And so you can kind of go back and refresh if you need to on that. So then I want to make my ion of sodium. So here we're going to do an ion of sodium. And so my number of protons has to stay the same because I'm still sodium. But in order to make that ion, what am I going to do with this one sad old valence electron? It's going to lose that one valence electron. So if it loses that one valence electron, now I have 10 electrons total. In those 10 electrons, I have 8 valence electrons and 2 inner electrons. So I've completed my octet. I'm happy, but my charges don't equal anymore. Now I have 11 positives and I have only 10 negatives. So what's the difference between the two? A +1. So when I write my sodium, I have to write a plus there. So it looks just like neon now, because sodium has 11. If you kind of zoom out and come over here, neon is the one that has 10. So what we say is the sodium ion is isoelectric to neon, which means it has the same electron configuration. So that's the same electron configuration. Okay. So now let's try the next one. If an atom of oxygen contains 6 valence electrons and an ion of oxygen contains 8 valence electrons and has a 2 negative charge, or a -2, what did the oxygen atom do to become an oxygen ion? Well, it's the same sort of deal, right? Okay, if I start out as an atom of oxygen, so here I am, here's my atom of oxygen. It's in group 6A, right? So that tells us what's going to happen, but let's break it down. What does this 8 up here mean? This 8 tells me I have 8 protons. If I have 8 protons and I'm in a neutral atom, I must have 8 electrons. So if I have a positive 8 and a negative 8, my net charge in the whole atom is 0. And that makes it, yes, a neutral atom. That is correct. Okay. So of these 8 electrons, how many are valence? 6 of them are valence electrons, and only 2 of them are inner electrons. So 6 plus 2 gives me the 8. All right. So what is this oxygen atom going to do? 6 valence electrons is not good. It wants 8. So now, instead of losing, we're going to gain. And how many do we need to gain? We need to gain to get 8. So 6 plus 2 is 8. So we're going to gain 2 valence electrons. Now I have an ion of oxygen. That ion of oxygen still has 8 protons. And it had 8 electrons, but it's now going to gain 2 more. So now I have 10 total electrons. Of those 10 electrons, it now has 8 valence electrons, and then the rest of them are 2 inner electrons. So now it has that complete octet, and it's very, very happy. What does it look like? Well, if I'm oxygen and I go from 8 electrons to the atom that has 9 electrons, I look like fluorine, but I didn't just gain 1, I gained 2. So now I have 10 total electrons with 8 valence, and I look like neon. So this is isoelectric to neon. So they're both isoelectric to neon. But what's that charge on the oxygen ion? Well, if I have 8 positives and I have 10 negatives, mathematically that gives me a -2. So I have a 2 negative or a -2, however you want to say that. Okay. So you have to just do lots and lots of these. An ion of calcium is written as Ca2+. Write the symbol for the ion formed from an atom of sodium. So sodium, if I look on the periodic table, come on all the way over here. We've already circled sodium. Sodium, right, has done what? Here we go. Its 1 valence electron is lost, and we make an ion that has a charge of +1. So we put the symbol Na, and we put a plus because it has a charge of +1. Write the symbol for oxygen, O2-. That's what we already did. So hydrogen's really weird. I told y'all hydrogen's weirdo. Hydrogen can either form an ion as H+, or it can become H-. How many protons and electrons are present in each? So let's start with H+. How could I get H+? Well, I know in a hydrogen atom, right, the atom, I have 1 proton and I have 1 electron. So in order to be H+, I'm going to have to lose this 1 electron. So H+ is going to have that same 1 proton, but it's not going to have any electrons. So the loss of the electron makes it an H+. And so sometimes we call H+ a proton. Why? Because H+ is a hydrogen atom that has lost its electron. It's a single electron. It's only electron, it's valence electron. And so all that is left is 1 proton. So that's why we call it a proton. Okay, then we need to talk about our H-. So what if we have H-? Well, I have to have a proton, right? So otherwise I won't be hydrogen. So what do I do in order to make H-? Well, I have to have 1 more electron than I do proton. So I would have to have 2 electrons in order to have a charge of -1. All right, so the group A elements are called the noble gases, or sometimes inert. We talked about in class, they don't really react because they have really stable electron configurations. So why might ions of the main group elements contain the same number of valence electrons as our 8A? Well, all of our elements, right? All of our elements want to form that stable octet. Our stable octet. And really there is an exception, right? Hydrogen, right? We won't say hydrogen. We'll just say sometimes it's an octet or sometimes it's a complete outer valence shell, right? Either way, whether that's 8 or that's 2, they want a complete stable octet. So what are our elements going to do? If they want that stable octet, the elements will gain, lose, or share valence electrons to complete their octet or to form the octet, right? The noble gases already have that octet. And so when we talk about gain or lose, this is our ionic compounds. When we talk about share, that's our covalent compounds. So how many valence electrons are present in the following atoms? Well, oxygen, right? Oxygen, if we come over here, is in 6A. How many valence electrons? You're going to have 6 valence electrons because you're in 6A. Phosphorus, we're going to have 5 valence electrons because we're right here and we are in group 5A. K, potassium, group 1A, so it's going to have 1 valence electron. Aluminum, right here in group 3A, so it's going to have 3 valence electrons, right? Okay, and then for number 2, for each of the atoms in question 1, determine the minimum number of electrons an atom needs to gain, lose, or share to become a stable, to have a stable outer electron configuration, which means you are isoelectric with a noble gas. So oxygen is going to do what? So oxygen here is going to gain 2. Once it gains 2 valence electrons, it's going to have a charge of -2, and it's going to look like, scroll over, 1, 2, it's going to look like neon. It's isoelectric to neon. Okay, phosphorus. What is phosphorus going to do? Phosphorus is in 5A. Okay. So the easiest thing to do for phosphorus is to gain 3 valence electrons, right? Go on to potassium. Potassium's in group 1, right? 1 valence electron. So it's going to lose, that's the easy thing, lose its valence electron. Lose 1 valence electron. Then aluminum. Aluminum has 3. Here's aluminum. So what's it going to do? Easier, way easier to lose 3 than to gain 5. That's not going to happen. So we're going to lose 3 valence electrons. Okay. All right. So how many valence electrons are present in the following atoms? I agree with this. I'm going to add something to it. So what I want you to give me is the number of valence electrons, whether they're going to gain, lose, and how many, what's going to be the ion's charge, and what would these ions be isoelectric to? So I guess I should write that. Ions, the ions are isoelectric to what? Okay. So let's look at number of valence electrons. We're going to just do one element at a time here. So neon, nitrogen, right here is in group 5A. So it has 5 valence electrons. What's it going to do? Lose 5 or gain 3. It's going to gain 3 valence electrons. If it gets an extra 3 negatively charged particles, it's going to have a charge of -3. And if you wanted to write the symbol, scooch this over, right? It would be nitrogen 3-. That's how you would have to do it for the homework. So who is he isoelectric to? Well, let's kind of clean this up a little bit. Gotta clean it up often, huh? Okay. So if I am neon, I have 7 electrons. I'm going to gain 3. I'm going to go 1, 2, 3. Who am I isoelectric to? I am isoelectric to neon. Okay. Magnesium. How many valence electrons do we have in magnesium? Coming all the way over here. Oh. Clean this up a little bit. So in magnesium, we're in group 2A. So in group 2A, everybody has 2 valence electrons. We're going to lose 2 or gain 6. We're going to lose 2. If you lose 2 electrons but keep the same number of protons, that means you're going to have 2 more protons than electron. So you're going to have a charge of plus 2. So if I wrote the symbol, that would be Mg 2 plus. So if I'm Mg and I'm going to lose 2 valence electrons, I'm going to start at 12. I'm going to lose 1, be it sodium. I'm going to lose another one, and I got to go to the second. See how I'm in the 3rd period? I got to go to the 2nd period, but I got to go all the way over here and end up at neon. So these 2 are isoelectric to the same noble gas. N3- is isoelectric to neon, and Mg2+ is isoelectric to neon. All right, sulfur. Sulfur, so clean this up a little bit more. Sulfur right here is in 6A, so it has 6 valence electrons. Anything that has 6 valence electrons is always going to gain 2 valence electrons. It's going to therefore have 2 extra negative charges and have a charge of -2. And we would write that S2-. That's the symbol of the ion. And so who is he isoelectric to? Well, if sulfur is going to gain 1 valence electron, it'll look like chlorine. If he gains 2 valence electrons, now he looks like argon. But you're always going to end up with something that's a noble gas. If you're turning something into a ion, it's gonna be isoelectric to noble gas. Carbon, how many valence electrons? 4 valence electrons. What is it going to do? It will not gain or lose valence electrons. Won't do it. It's too much energy. It costs too much energy. So it will share valence electrons. And we'll talk about that a little bit later. All right. So, and we did 4 already. All right. So complete the following statements. An anion, so an anion, positive or negative, that would be negative, has more or fewer protons than electrons. If something is negative, then it's going to have more, it's going to have more electrons or fewer protons, right? So if you have something, for example, like nitrogen, right? Nitrogen has 7 protons and it has 7 electrons. But we know nitrogen atom is not stable. It's not happy, right? Because of those 7 electrons, we're in group 5A, you're going to have 5 valence electrons. So what's it going to do? Ooh, that's terrible, right? So we're going to turn into the nitrogen ion, and that nitrogen ion, we want 8 valence electrons. So how are we going to get from 5 to 8? We are going to gain 3 valence electrons. Easier to gain 3 than to lose 5. So now I go from having 7 protons, if I've gained 3 valence electrons, to now having 10 electrons. So my total here is I have a +7, I have a -10, that gives me -3. So this is a 3-, N3- is the ion. So I just made an anion because it is negative. I made an anion. So an anion has fewer protons than electrons. This only had 7 protons, whereas we had 10 electrons. So the electrons found in the outermost shell of an atom are called valence electrons. Oh, they already have the word electrons. Okay, ions formed from metals have a positive or negative charge. Well, metals, everything on the left-hand side of the periodic table, all of this blue stuff, that's going to all make positive, right? +3. Where's my +2? My +1. All the stuff over there is going to make positive or cations. Okay. All right, an ion is charged because the number of blank and electrons are not the same. Protons and electrons. An ion that has a positive charge is called a cation. If I can write. Oh, I'm on eraser. Cation. Let's see. The ion formed from a sulfur atom is called, now we have to name it. So we take the name of the element, if it's a metal. So this is, oh, no, this is sulfur. So this is a non-metal. So the rule for a non-metal, right? A non-metal is going to turn into an anions. So an anion is going to end in IDE and then ion. So our example is fluorine. Fluorine's on the periodic table. If we turn it into an ion and make it F-, it's going to be the fluoride ion. So if I have sulfur, that is going to be the sulfide ion. If, on the other hand, you had something that was a cation, like magnesium. Magnesium, if you turn it into an ion, is going to have lost its 2 valence electrons. And so all you do is put the name of the element, magnesium, and then put the word ion behind it. Pretty easy stuff. All right. Hope this helps. And stay tuned for part 3.